Hello everybody, welcome or welcome back to my channel. So from today onwards, we'll be doing SEM and exam preparation of electrical engineering. So the first chapter is power plants and DC circuits. This is the list of topics present in this chapter. I cannot finish all of these topics in one single video because of its length. So I'll be dividing it into parts. So in today's video, we'll be covering one of the major portions that is up to we'll be doing Ohm's law, limitation, CDs, parallel connection, the numericals based on that, current division rule, voltage division rule, and its numericals, unknown resistor numericals, KCL and KVL with numericals. I'll be doing up to here today. And I'll be doing special case of KVL in the next video. And in the next part, I'll be covering the remaining topics power system, types of power lines, and power plants. Based on its length, I'll be dividing that also into parts. So let's finish this much part today. We'll be covering almost half of the chapter, if we complete this much. So let's begin quickly. So it's because numerical space, it would be nice if everyone has a calculator with them ready to solve. And yeah, we're bound to mistakes. We'll cross check slowly and go. There's nothing. There's no happy that we're going to finish it soon. We're going to go to normal pace. So let's start with the first topic. Let me add some pages before that. So first topic is Ohm's law. This is something we've been learning since many years now. We know the formula V is exactly proportional to I. We know V equals to IR. Okay, let me read the definition. At constant temperature and pressure, the potential difference across the conductor is proportional to the current flowing through the conductor. What do we see? At constant temperature and pressure, the current flowing through the potential across the conductor. Remember, V is first. V is first. The potential across the conductor is directly proportional to the current flowing through it. Okay, this is the definition of Ohm's law. V is voltage, I is current, R is resistance. V is directly proportional to I, V equals to IR. Remember, V is directly proportional to I, V equals to IR. Because by chance, directly proportional doesn't mean I directly proportional to V. This would be wrong. Because then you let I equals to V, the whole formula gets wrong. So this is wrong. Don't write like that. Remember, because V is directly proportional to I, V. Okay. Then now P equals to VI. This formula we know. Then if V equals to IR, then I can add P equals to I square R. And if I equals to V by R, I can add P equals to V square by R also. Correct? P equals to VI, P equals to I square R, P equals to V square R. All are in watts. These are the equations of power and all are in watts. I'll just tell you when do we use watt also. This P equals to I square R for power dissipation when current is given, and for that power dissipated we have to find. That time we can use P equals to I square R. P equals to VI and P equals to V square by R. You can use it for total power. For current dissipation, use this. For total power, use this. Though current is given in this, better to use this for total power. And for current dissipation, use this. P equals to I square R. Okay. Now let's see some graph. By the way, let's see the graph also. The graph V here, I here. Remember that also. Some people write VI. No. Write it as V should be in x-axis and I should be in y-axis. The graph we know is linear. This will be delta V and this will be delta I. Delta I. Okay. So limitations of Ohm's law. Let's see the limitations of Ohm's law. Ohm's law is not applicable for the semiconductor devices like Zener diode. First one is it's not applicable for semiconductor devices. like Zener diode. Ohm's law is not applicable for non-linear devices. Even for non-linear devices, it is not applicable. Then it is not applicable for non-metallic conductors. Non-metallic conductors like silicon carbide. An example for non-linear is again Zener diode or transistors. For this also, Zener diode is an example. If you remember one example, I'll use it for multiple things. It's nice, right? So, and one more disadvantage is the temperature should be constant. Remember the definition I told you? At constant temperature and pressure. So, temperature should be constant, which is also a disadvantage. So, limitation says it's not applicable for semiconductor devices, it's not applicable for non-linear devices, it's not applicable for non-metallic conductors like SiC, and it's not applicable for it's not, and for this temperature should be constant. That's also a limitation. So, this was all about Ohm's law. Right, definitions for a constant temperature and pressure. The potential across a conductor is directly proportional to the current flowing through it. V is directly proportional to V equals to IR. Which for power equations, P equals to VI, P equals to, if we remember this formula, if we substitute IR, so it will become I square R. If we substitute V as I as V by R, it will become V square by R. So this is the power equations. This is the graph of Ohm's law. P equals to I square R, you can use for power dissipation. P equals to VI and P equals to V square by R for total power. Limitations is not applicable for semiconductor devices, not applicable for non-linear devices, not applicable for non-metallic conductors, not applicable. It's not for this temperature should be constant. So again, it's a limitation. Okay. So we have finished the first topic, that is Ohm's law limitations. Very good. Now let's go to series and parallel. This is also again a very simple topic. From here, numericals will start. So let's be a little bit more conscious. So series connection, and you will have parallel connection. Series and parallel. So see, we all know in series the current is same, and in voltage the I will just write the first diagram first. R1, R2. So this will have a different V1 and this will have a different V2. So here current is same and potential is different. Here your potential is same. Your potential is same. But current is different. Here I1, here I2. But here common current I. Okay. And this is R1, this is R2. Similarly, this is R1, this is R2. Okay, that I have done. So here in parallel, what we see here, potential is same and current is different. Diagram also just simple. Series for parallel. That's it, parallel. Diagram also keep learning, okay, because diagram will show that you actually know. Series and parallel, basic difference you have learned. Current is same, potential is different. Potential is same, current is different. Okay. Now, potential is different. So, V1 equals to IR1. V2 equals IR2. So, V equals V1 plus V2. Okay. Here current is different. So I1 equals V by R1 because it equals to IR, right? So I2 equals V by R2. What is different? That only we can write I1, I2, V1, V2, correct? So now R equivalent for series, we know this R1 plus R2 and so on. And R equivalent over here is going to be, either you can write as R1, R2 by R1 plus R2, but this is going to be for two resistors. For more than that, 1 by R equivalent is equals to 1 by R1 plus 1 by R2 plus 1 by R3, so on. It's only fine if you have forgotten these formulas. It's not going to show in all your devices. Now you have learned it, now you will remember it. Okay. So for two resistors, we have to use this, but if not, this 1 by R equivalent is 1 by R1 plus. So after solving, you have to get into R equivalent term. Okay. And here R equivalent is R1 plus R2. So R equivalent here will be greater than R1 and R equivalent also be greater than R2 as well. Okay. For n identical series combination, it's going on, say it's going on, for n identical resistors are connected in series. Identical means all of these have, say, 2 ohm, 2 ohm, 2 ohm, 2 ohm, 2 ohm, all of them have 2 ohm. For that, R equivalent will be NR. NR. Okay. N is number of resistors, here is the value. For parallel, for n identical parallel resistors, say 2 ohm, 2 ohm, 2 ohm, 2 ohm, then it goes on. Then for what is the equivalent resistance here? It will be R by N. It will be R by N. That's it. For this, we are done with the formula revision. I'll quickly revise. In series connection, the current is same, the potential is different. In parallel connection, the potential is same, the current is different. So in series, it will be, will be in terms of I1 and I2, will be in terms of V1 and V2. Here V equals V1 plus V2, that will not be understood, right? And here R equivalent is R1 plus R2. Here R equivalent is 1 by R1 equals 1 by 1 by R equivalent is equals to 1 by R1 plus 1 by R2 plus 1 by R3. For n equivalent resistors, here R equivalent is equals to R into N or N into R. And here for n parallel resistance which is identical, the R equivalent will be R by N. That's it. Using these formulas, we'll be able to solve the questions. So let's quickly start solving the questions now. So going with question number 1. Simple only. A, B. This is 2 ohm, this is 8 ohm, and this is 2.4 ohm. Let me just use across it. Yes. So first, let's solve this part. What first part you're solving? Write that first. Now we can see this is in parallel. You can see it's branching here. I will explain so in the beginning. Afterwards, you can get up the momentum. It's branching here, so we know it's parallel. So we have to find, what should we find? We have to find the R equivalent, obviously, right? So R equivalent, let us try to find. So R equivalent equals to 2 into 8 by 2 plus 8. You can write the formulas first and all of that you can do. Here I'm just doing a little bit directly. 8 to 16, so that will be 1.6. Now redraw the circuit. This part, though you'll feel you know, better to redraw. Why to risk? So now we know it's in series. So R equivalent, here I can write as RP first because that is not R equivalent, right? That is not R equivalent. R equivalent, so now we are getting. So RP I'll write here. And now I'll let R equivalent equals to 1.6 plus 2.4. That is going to be 4 ohms. Ohms, don't miss again. Done. First question is done. Let's go to the next question now. I'll draw the diagram roughly to prevent wasting time. This is 1, 3, 5. This is connected to this, which is 4, 6. This is A and this is B. So one thing you have to remember is that don't think this is in a straight. Don't, I know this is a very uncommon mistake, but don't take this like that line is serious. No, that's not how it works. Treat this as separately and treat this as separately. So first you want to start with this. We can start with this. I'll take this as RP2 now. So RP2 is equals to 4 into 6 by 4 plus 6. 24 by 10, that gives 2.4. So I just redraw the circuit. But I can solve this also directly now, right? It's not dependent on it. So I'll take this as RP1. So RP1. So that I have to solve. So 1 by RP1. RP1. So 1 by RP1 equals to 1 by 1 plus 1 by 3 plus 1 by 5. So let me just solve it using calci. So I get 1 by RP1 as 23 by 15, but we want RP1, that will going to be 15 by 23. It's going to be 0.6521. I'm getting this RP1. So now let me redraw 0.6521, and here we got 2.4 A and B. Now this is in series. So now I can write R equivalent equals 0.6521 plus 2.4, which I will get it as 3.0521 ohms. This is the second answer. I hope you've understood it well. Let's go to the next question. This question is slightly lengthier, but it's not hard. So again, you have parallel connection here, and then this is going to become again branching out here, and then this is going to continue to this. Then from here it's going to come, and yes, that's how the diagram is. I've drawn it in a very rough manner, don't mind. That's going to be B. Here you have 5 ohm, then here 2 ohm, 5 ohm, 10 ohm, 4 ohm, 6 ohm. This is 1.35 ohm. Okay, 2 ohm, 5 ohm, 10 ohm, 5 ohm, 4 ohm, 6 ohm, 1.35 ohm. Yes. So let's solve this now quickly. First, I would like to solve this one and this one. So I'll take it as RP1 and this is RP2. So RP1, to solve 1 by RP1 equals 1 by 2 plus 1 by 5 plus 1 by 10. So let me just solve that. 1 by 2 plus 1 by 5 plus 1 by 10. I'm getting that as 0.8. So RP1 will be 1 by 0.8, which is going to be 1.25 ohms. Now RP2 similarly, if I solve, this I can solve directly. First two resistors, 6 into 4 by 6 plus 4. That will be 24 plus 10, that is going to be 2.4 ohms. So now let's redraw the circuit first. This is 0.8, this is 2.4, and this is 1.35, and this is 5 ohms. So what do we understand from this much is in series, then we can write it as RS1 equals 6.8 plus 2.4 plus 1.35. That I will get it as 6.8 plus 2.4 plus 1.35. I'm getting it as 10 point. Once again, where did 6.8 come from? 1.25. Where did 6.8 even come from? My bad, guys. RS1 equals 1.25 plus 2.4 plus 1.35. So 1.25 plus 2.4 plus 1.35. That will give you 5 ohm. Now let's redraw it again. 5 ohm and 5 ohm. So now either you can use an equivalent resistor which is in series, in parallel, or you can use the 5 into 5 by 5, 5 plus 5. I'll use equivalent resistors in parallel. So R equivalent will be R by N. That'll be 5 by 2. That'll be 2.5. This is my R equivalent ohms. That's it. We're done with the next question as well. Let's move to the next question. This is a simpler question again. We have parallel resistors here, and then goes like this. This is going to come in between these two resistors. This 5 ohm, 3 ohm, 6 ohm, 18 ohm, 8 ohm, A and B. Now what you have to observe and understand here is that these two might look like they are in series. These two might look like they're in series, but they're not, because they have a branching here. If you see any breakout or branching, that means that it's not in series, though they might be in a straight line. We cannot take that as a series. You cannot even take this and this in series, but because again there's a branch out there. Okay, that's what I wanted to tell, and I think I've made you understand that well. So let me start with solving this first. So I'll take it as RP1. So RP1 equals 3 into 6 by 3 plus 6. So that'll be 6. This is the 18 by 9. That's going to be 2 ohm. If I am to read the circuit, it'll be something like this: 2, 18, 8, 5. So this I will take it as RS1 now. RS1 equals 2 plus 18, that is 20 ohm. Now again let's redraw. 28, 5. These are in parallel. RP2. So RP2 equals 20 into 5 by 20 plus 5. That's going to be 100 by 25, which is going to be 4 ohm. Now 4 and 8. This I can take it as R equivalent, that is equals to 4 plus 8, that is equals to 12 ohm. That's it. We are done. That's it. Let's go to the fifth question now. It's slightly lengthier, but it's not hard. And then outside also you have 1, 8 ohm BA, 12 ohm, 4 ohm, 2.1 ohm, 1.9 ohm, 3 ohm, 6 ohm. Okay, this is the question. Let's solve this. I can first directly I can see that here I have 1. Remember, we cannot take this and this because it's a branching here. So this again won't be counted as series. Okay. So I'll do this first RS1 simultaneously. I can also do this one as RP1. Right. So RS1 will be 2.1 plus 1.9. So 2.1 plus 1.9 will give me 4 ohms. And RP1, 3 into 6 by 3 plus 6, 18 by 9, that is 2 ohm. Now let me redraw the circuit once. 4, 2, 8, 4, 12. Now clearly we can see that this is in series. So it is RS2. RS2 is what? 4 plus 2, that is 6. Now again I have to redraw. 12, 6, 4, 8. Now all of these are in parallel, so I take it as RP2. So 1 by RP2 equals 1 by 12 plus 1 by 6 plus 1 by 4. That will be equal to 0.5. But we want RP2, that is equals to 2. So now again if I have to redraw the circuit, 2 and 8 will be there. Now again this R equivalent equals to 2 plus 8, which is equals to 10 ohms. Important that you read the circuit in each and every step. Now we have the hardest question of all of these questions. Okay, that is slightly hard, so we'll have to go very slowly. Do not rush it. Okay, drawing it is also hard. I'll take some time. Just give me some time. It's not hard that way. I mean, it's way lengthier. It's way lengthy. That's how I said like that. But doing wise, it's okay. It's not that. We'll see. Bound to mistake this question is, but yeah, we'll try to prevent it. This is the diagram. 30 volts. The question is to find the current flowing through it. 5, 5, 10, 5, 10, 5, 5, 5, 5. You have to find the current flowing through it. In such type of question, start from the opposite side. Okay, from this side you better start. Okay, let's start. Slowly we'll analyze. What now can we do first? That let's focus. This I can see that we can solve this as RS1. We can solve this as RS2. Anything else we can solve? Not nothing as of now. So let's solve RS1 and RS2. RS1 we know is going to be 5 plus 5, that is going to be 10. And RS2 is also going to be 5 plus 5, that's going to be 10. First redraw the diagram. However you understand, you draw. We can see that these two are in parallel. Similarly, these two are in parallel. RP1, RP2. So RP1 will be 10 by 2, 5. RP2 also be 10 by 2, that is going to be 5. Redraw the diagram. 5. Here also 5. Here also 5. 5. 5. These two are in series, we can see. So RS3 equals 10. Redraw the diagram. This is 5, 5, 5, and this will be 5 plus 5, 10 now. These two are in parallel. RP3. So RP3 is 5 into 10 by 5 plus 10. 50 by 15 I am getting. That is giving me 3.333. That is going to be equal to 3.333. 3.333. This is going to be 5. This is going to be 5. Now again this will be in series. So RS4, I think RS4 is 5 plus 3.333. That is going to be 5 plus 3.333, 8.333 approx. So now again redraw. 8.3335. This is in series or parallel. Analyze that first. You only think. Here, this is the part where we get stuck. It is going to be parallel, okay? It is parallel. So, R equivalent equals 5 into 8.333 by 5 plus 8.333. That is 3.1249 ohms, which I am getting approximately. But the question doesn't finish here, end here. The question is to find current. So voltage they had given us 30 volts, and we have to find the current. And R equivalent we have find 3.124, and always you have to find the current based on the R equivalent, not in any random resistance. Okay, so V equals to IR, I equals V by R. So 30 by 3.1249, basically 125, but yeah, 30 by 3.1249. Approximately I'm getting 9.6003 amperes. So that was the question. Next is current division rule and voltage division rule. So what I'm thinking is I'll just to make it into the next video, though I thought of covering all of that in this video itself. Remember, I'm also covered KCL KVL, but yeah, I realize it's going to be too long. So until now I've just covered this much. In the next video again we'll go on doing it in parts. So see you in the next one. Until then, bye bye.